Alright, so you've been learning lots of rules about the multiplication and division properties of exponents, and I just want to put it all on one paper so that you've got a study guide and you know what all the rules are. So this paper is a good study sheet. So we're going to talk about the rule breakdown. So the very first thing you learned was when multiplying numbers with the same base, what do you do? If you know it, write it down. You add the exponents. That's what you do. You add the exponents. So then I've got 3 examples here of that. So the first one, x to the a times x to the b. Because these guys have the same base, you add the exponents. So it's going to be x to the a plus b. Again, if you think you can do these without my help, you should stop the video. I encourage you to fill out the whole top part of this sheet and then come back and make sure that you've got the right answers. And then you can fast forward through the video. So the next one, x to the 3rd times x to the 5th, you add the exponents. So it becomes x to the 8th. The next one, keep in mind that that negative sign there, we're going to replace it with a -1. So this problem really is like 5x to the 4th times -1x to the 6th. Okay? Now, the rule is add the exponents. We're not adding everything because technically we're multiplying, right? It's repeated multiplication. 5 times -1 is just -5. And then you add your exponents. 4 and 6 is 10. So it's -5, x to the 10th. Alright, so when taking an exponent to another exponent, this is really taking a power to another power. What do we do in this case? Look at these examples. What would we do in that case? We would multiply the exponents. There you go. Alright, so in this case right here, if these were actual numbers, what would we do with a and b? We would multiply them. So this is x to the ab, and we put ab next to each other because that's a multiplication. This next one, this would be x to the 12th. Alright, this next one, there's a negative sign there. So this really technically is like doing -1, x to the 6th to the 3rd. That negative sign is not actually attached to the x. So it's like we're doing -1 to the 3rd power. So this -1 is going to the 3rd power, which means it's going to stay negative. So this final answer is going to stay negative. Multiply the exponents, 6 and 3 is 18. So this answer is -x to the 18th. Alright, the next one, technically, again, you're multiplying right here. This negative here is attached to that 6. Okay? However, because of the brackets, you can multiply these together, and it looks like this to start with. It's like -x in parentheses to the 18th, and then from here we can look at this and be like, well, that's even. A negative to an even power is always a positive. So the most simplified answer for this is positive x to the 18th. Okay, so when there are multiple factors being taken to an exponent, like there's 2 things being multiplied together, that's also being taken to an exponent. The rule here is kind of like the distributive property, but we don't call it the distributive property. You bring the outside exponent to all of the exponents on all of the factors on the inside. So what I say here is apply, I'm writing up here because my line isn't big enough, apply the exponents to all factors. And factors are things that are being multiplied together, numbers, variables, symbols. Okay, so in example 1, xy to the a, that would just be x to the a power times y to the a power. Done. Example 2, keep in mind that the 3 technically has a little 1 exponent on it. So really what I'm doing is 3 to the 4th power, x to the 12th. Multiply the exponents. You're not multiplying the coefficient by the exponent, you're taking that big number, that coefficient, to the exponent. So 3 to the 4th is 81 x to the 12th. And so I do that really fast in my head, kind of by pairing up two sets of 3s, right? 3 times 3 and 3 times 3 is 9, and then you have 9 times 9 is 81. That's how I end up doing it. Instead of 3 times 3 is 27, or times 9, and then times 9 times 3 is 27, and then 27 times 3 is 81. I think it's easier to just pair all 4 of them together like that. The next one, negative 3 to the third power. Technically, this looks like this. You do, or negative 3x squared to the third power, so it's negative 3 to the third, x to the sixth. And negative 3 to the third, negative 27. X to the sixth. And then the next one looks like this. You're taking negative 3 to the second power, x to the sixth power. So like this outside guy is coming in to everybody. This negative 3 technically has an exponent of 1. Negative 3 squared, the negative is included in that. So it's 9, x to the sixth. Negative 3 times negative 3 is positive 9. Alright, so now moving on to the newer concept, dividing numbers with the same base. So when dividing numbers with the same base, you learned that what we do here is we subtract the exponents. Subtract the exponents, or you're like canceling them out. So right here, k's, they're the same base. What would I do with those exponents if they were numbers? Well, I would subtract them. So this would be written as k to the h minus r. The next one, d to the 15th over d to the third, you have the same base, subtract the exponents. So it becomes d to the 12th. Now this next one, you have a fraction, right? So remember 8 and 36 in this problem, they're not exponents, they're coefficients. So if I covered all of the variables, I would have 8/36. Well, 8/36 is a fraction. 8 over 36 reduces, you can divide 8 and 36 by 4. 8 divided by 4 is 2. 36 divided by 4 is 9. And then the m's, m to the 5th over m, well, that would be m to the 4th on the top. Why is it on the top? Because we have more on the top than the bottom. So we're canceling the 1 m at the bottom off from the top. Now the next one, the n to the 3rd over n to the 6th. Here, you're canceling out these 3 n's up here, which leaves you with 3 n's on the bottom. So you're left with n to the 3rd on the bottom. So just a visual again for this part. Remember, n to the 3rd is n times n times n over, divided by n times n times n times n times n times n, right? 6 n's. Keep in mind, these cancel out to give you 1's. You're left with just a 1 on the top and n to the 3rd on the bottom. So the end of the 3rd ends up being on the bottom. So that's why the end of the 3rd is on the bottom, because there's more on the bottom than there is on the top. So more with the new stuff. When a fraction or a quotient is raised to an exponent, well, what do we have to do? Just kind of like we did with when we have a product or factors. We apply the exponent to the numerator and the denominator. Or you could say the top and the bottom, but it's better to say the numerator and the denominator. All right, so here I have a w on the outside of parentheses. We're going to bring that in. So it's going to give me m to the w over n to the w. Example 2, you have to bring the 3 to the top and the bottom. So I'm going to do m to the 3rd over, it would be 3 to the 3rd, not 3 times 3, 3 to the 3rd, which is 27, not 9, right? 3 to the 3rd, 3 times 3 times 3. Example 3, 3g over 5h to the 4th, bring the 2 in to everybody. So on the top, 3 to the 2nd is 9. G to the 2nd. 5 to the 2nd, 5 times 5, 25. H to the 8th, 4 times 2. Okay? The next one, I'm going to put it down here. You got negative 2 in there. You're taking negative 2 to the 4th power. Well, over here, negative 2 to the 4th power. Again, if you're taking some of the 4th power, I like to pair things up, right? This is 4 times 4. That's positive 16, right? So negative 4 to the 4th power is 16. P to the bring the 5 and the 4 together, that's 20th. You're multiplying the exponents because you're bringing an exponent from the outside in, and then you also have to apply it to the bottom, x to the 4th. Okay, and so now combining all of the properties. I'm writing you a helpful hint here. So when any of the three things above are happening at the same time, just follow PEMDAS, right? Parentheses are grouping symbols, exponents, multiplication, division, addition, and subtraction. We can cross off addition and subtraction here in this case because we haven't talked about what to do when we're adding and subtracting things with powers, okay? But basically, what I'm trying to say here is simplify the inside of parentheses first, then simplify the rest, okay? So in example 1, instead of bringing the 2 to the -2 and to the d to the 3rd and the c to the 9th and to the 3 and to the d to the 2nd, look at what's happening inside the parentheses first, right? Can I combine any of this stuff? You absolutely can. You can divide -2 with 3. These are just regular numbers, so just multiply them. -2 times 3 is -6. Then I can combine the d's. D to the 3rd times d is d to the 4th, because d counts as 1, and then c to the 9th. You're taking that whole thing to the 2nd power. So now all three of those factors are going to the 2nd power. So -6 to the 2nd power, -6 times -6 is +36. And then remember, we're multiplying the exponents, so it's d to the 8th, c to the 18th. And then usually we would write this as 36, c to the 18th, d to the 8th, because we like to keep things in alphabetical order, but it's not wrong if you don't. Okay? All right, so now the next one. Lots of people will immediately look at this problem and bring the 2 in and then go from there. But you don't have to do that. You can combine the inside here first, then bring the 2 in. Combine the inside here, then bring the 3 in. So it's like you're doing what's inside the parentheses first, then you're squaring, then you're cubing. Okay? So let's combine the inside. Inside I can combine those a's. So here you're adding the exponents because you're doing a to the 5th times a to the 5th. So you're counting up the total number of a's you have. So inside the parentheses you have 2a to the 10th, b. Outside the parentheses you still have that little 2. The next set, you can combine the b's. So I'm going to combine the b's after I write down the 4a to the 3rd, because I like to keep things in alphabetical order. So b to the 9th, because you're adding the exponents. You're taking that whole thing to the 3rd power. So now bring in the 2 here. So it's going to everybody. 2 squared is 4. What do I do with the exponents? I multiply. A to the 20th, b to the 2nd, times 4 to the 3rd. Well, 4 to the 3rd is 64. A to the 9th, b to the 27th, because you're multiplying the exponents. So now we can combine all this together. 4 times 64 is 256. A to the 20th times a to the 9th. Add the exponents. A to the 29th. B to the 2nd times b to the 27th. B to the 29th. And that's your answer to that one. All right, example 3. Let's get rid of this so I have a little bit more room. I'm going to move it over a little bit so we can look at this problem. Now, this one, I'm going to put a star by it because this is the thing I say over and over and over again. You want to simplify the inside of this first because 10 over 30 reduces to 1/3, right? And it's easier to take 1 to the 2nd power and 30 to the 2nd power than it is to take 10 to the 2nd power and 30 to the 2nd power. You might be like, whatever, 10 to the 2nd power is just 10 times 10, which is 100, and 30 to the 2nd power is 900, but then you have a fraction that's 100 over 900. That's a simpler fraction to reduce, but why? Why do you want to reduce it when it's that big, right? It'd be like if I had like 12 over 14, and you're doing 12 to the 2nd and 14 to the 2nd and then reducing it. That's crazy. Reduce first. Reduce first. Reduce first. Reduce first. Reduce first. Say that 10 times fast. All right. So when I go to reduce the inside first, 10 over 30 reduces to 1 over 3. I'm just going to put a 3 at the bottom. You don't even need the 1 at the top, because guess what? You're going to have some a's at the top. A to the 6th over a to the 3rd. Subtract those exponents, you have a to the 3rd on the top. J to the 2nd over j to the 8th, you're canceling out the 2 on the top to leave you with 6 on the bottom. Now take it to the 2nd power, and then it's going to be already reduced. So then when you bring that 2 in to everybody, you get a to the 6th over 9j to the 12th. Okay? Good luck. Finish the rest on your own. And ask for help if you need it. Good luck!